Hello all, today in this video I am going to make an FTRL optimizer with RNN algorithm. This is the continuation of previous video only. Previously we have made some optimizers with RNN and we have made a comparison too. In this work we are going to work with FTRL and also we are making a comparison with FTRL too. So for that initially we are importing the libraries which we are needed. Then we are loading the heart disease dataset. This heart disease dataset we downloaded from Kaggle. This dataset is a heart disease prediction dataset. Kaggle, if you give means you will get this dataset. This dataset is having nearly 14 entries. Among that, the first 13 entry we are using as the X variable, and the last entry we are using target entry we are using as the Y variable. Then we are getting the info of the data set. From that you may notice that the only old peak is the float type and all others are integers, and then we are checking whether our data set is having any null values. You may notice that all the data entries is having 0 only. In that case we may notice that our data is not having any null values, so we have omitted preprocessing function. If it is having any null values means we have to work with some preprocessing functions. Then we are displaying the heat map of the data set. So this is the heat map of the heart disease data set which we are using. Then we are making the determination of the X variable and the Y variable as I said previously. Within the X variable, since all other variable rather than target is used, we are dropping the target and all others other than the target is used within the X variable, and within the Y variable only the target variable is used. And by this X variable and Y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. And by the use of train test split function we are determining variables like X train, X test, Y train and Y test. And within this X train and X test we have to make some vector conversion. For that we are using the standard scalar. Then we are getting the shape of the X train variable. Why? Because this X train we will be using as the input shape within the layer contribution. And also this RNN will use only 3-dimensional data, but you may notice that we are having only 2-dimensional data. So we have to convert our 3-dimensional data into 2-dimensional. For that we are using the reshape function. This reshape function is converting this 2-dimensional data into 3-dimensional. Then we are determining the layer contribution of the RNN model. It is having simple RNN layer with the input shape we have called over here. Then the activation as ReLU. Then the final dense layer as 1. Because our work is a binary classification work. For binary classification work we will give the number of classes as 1 and activation as sigmoid. If it is a multi-classification work means this 1 will be replaced by the number of classes we are having. And this is finally we are getting the summary of the model. So this is the summary of the model. Then we are compiling our model by using laws, optimizer as Adam and metrics as accuracy. Then we are training by our model by using the fit function and with the variables like all variables and approaches for 50 approaches. So for 50 approaches we are getting values like loss, accuracy, validation loss and validation accuracy. Then we are displaying the classification report. Within that we are getting variables like precision, recall, F1 score, support, accuracy, macro average and weighted average. By this we have getting nearly 99% accuracy. Then we are making a definition for the confusion matrix, and then based on that definition we are plotting a confusion matrix for RNN with the Adam optimizer. Then we have worked with SGD optimizer. All the layer contributions and all same only, but only the name will be different. Why? Because at the end we will be making some comparison. So at that time if the name is same means it will make some confusion. For that only we are declaring some different names, but apart from that all others are same only. And also the only thing varying is optimizer. Here we will be giving the optimizer as SGD. Previously it will be Adam and it will work for 50 approaches, and we have got the classification report and also the confusion matrix. Then we worked with rmsprop optimizer, where we have replaced the optimizer as rmsprop and worked for 50 approaches, and we have got the classification report and also the confusion matrix. For rmsprop also we have got nearly 100% accuracy. Then have worked with adadelta optimizer and replaced the optimizer as adadelta, which is worked for nearly 50 approaches, and we have displayed the classification report and also the confusion matrix. Then we worked with the adagrad optimizer and replaced the optimizer by adagrad, which is working for nearly 50 approaches, and we have determined the classification report and also the confusion matrix. Then we have worked with adamax optimizer. For that we have replaced the optimizer as adamax, and we have displayed the classification report and also the confusion matrix. Then we worked with an nadam optimizer, for which we replaced the optimizer as nadam and worked for nearly 50 approaches, and we have got the classification report as 100 and also the confusion matrix. Finally, we have worked with the FTRL optimizer. So we have replaced the name. Then we have replaced the optimizer as the FTRL. So this is also working for 50 approaches. For that, we are getting some less accuracy only, some 40% only. So the classification report also, you may notice the accuracy is 48% only. Then we are displaying the confusion matrix. This is the confusion matrix for the FTRL. Then we are making an comparison with all the optimizers. So this is the comparison for all the optimizers, and you may notice which line is for which line, and within this comparison graph we have determined the values like validation accuracy, training accuracy, validation loss and training loss. For optimizers like Adam, RMS RMsprop, nadam and all, it is showing some better accuracy, but some other accuracies is showing some less apart from the other optimizers. Same like loss. So this is the work for our RNN. Within the next video, we will be working with some other deep learning algorithm and will make a comparison with the different optimizers. If you are interested in making some other demo video, means please let us know in the comment box. So if we are aware of it, means we will definitely make a video regarding it. Thank you.